In today's notes, we're going to do applications of functions. We're going to do the first function word problem where we're given an equation and have to use it. A baseball team offers a promotion. Normally, it's $12 for bleacher seats, but every specially marked soda can take 50 cents off of the price. The function can be represented as f of x equals 12 minus 0.50x. So we're going to go ahead and define our variables first. So I'm going to think about what can change in this problem. Right away, I know I can change the number of specially marked soda cans I have. So that's going to go in for my x because I could have one, I could have two, I could have none, and I could have 100. What's going to change based off how many soda cans I have is the cost of our bleacher seat. Now we're going to go ahead and find the value of f of 2 here. So remember, I'm going to go ahead and copy down my f of x function from above that they gave me. F of x equals 12 minus 0.50x. And everywhere I have an x, I'm going to replace it with the number 2 here. And remember, x is going to be my specially marked soda cans. So I'll highlight that in blue to help me remember, especially for the next problem. Whenever I add an x, I replace it with 2. Remember, the left side's just a notation, so we're going to copy that down and ignore it. But we need to do PEMDAS and GEMDAS on the right side. Multiplication comes first, so I'll keep the 12, but I'll multiply negative 0.50 times 2, which will get me a negative 1. And then I'll go ahead and subtract 12 by 1 to get 11. Bring that function notation down to have the final answer in function notation 4. Don't forget, we can always do it in the Desmos calculator. Here's how. In Desmos, you type in the given equation, f of x equals 12 minus 0.50x. And then underneath, you put in what you're trying to solve. We're trying to find f of 2, type it in, and it gives me the answer of 11 right there, which checks our math for what we just did by hand. Now we're going to talk about what this means in context because that's going to be the answer to B. In the question we just solved, what it meant in context was that if you have 2 specially marked soda cans, then the price for that bleacher seat is going to be $11. For example C, we have how many specially marked soda cans. So I'll go ahead and highlight that on our blue because that's going to be our X value we're looking for. We're not given it, we're wondering how many. Do you need to only pay $10, so that's our number we're given, for bleacher seats? Well, that bleacher seat again was going to be my Y value. So here's the thing. I am given my Y or f of x value, but I'm not given my x. So how I'm going to set this one up is f of x equaling 12 minus 0.50x. That's just copying down the original function. But I have to keep x because I have to solve for it. But what I do know is my f of x or my y equals 10. So this is how I set up my equation. Solving it by hand, we go ahead and subtract 12 from each side, getting my x by itself closer to the goal. But now what I do here is I have a negative 0.50 multiplied to x, so I have to do the opposite, which is division. What I do to one side, I do to the other, and it cancels out here on the right, and I actually do that in a calculator on the left to get 4. Now that is going to be my answer, but let's put a unit on it to answer the question. How many specially marked soda cans? The answer is going to be 4 specially marked soda cans. Okay, let's do it in Desmos because again, you'll have Desmos the whole time with this. I just like to show you by hand first. This time we're going to go ahead and type in the equation that we replaced the f of x with. So that would be 10 equals 12 minus 0.50x. And we don't get our answer over here on the left column, but we get it visually on the graph. You'll see I have that point that the purple line goes through 4, 0. The answer is the x value because that's what we were looking for, the specially marked soda cans, which were x. And the answer was indeed 4. In the next application problem, we're going to learn how to read functions given a graph. The following represents the graph of f of x, and we want to find each of the following. The first one we want to find is f of negative 4. Remember, we just talked about when it's inside the parentheses, it's our x value. So what I want you to do is I want you to go ahead and find x being negative 4 on your graph. And we then do a whole highlighting of that x equaling negative 4. Let me hide that a little bit better. Because now I have to see where that highlighting meets my graph, and I can go ahead and circle it right here. That's where it hits the actual graphed line I have. I answer with the y value of that intersection, which is luckily going to be 0 here. So we're given the x and we have to answer with the y. Let's do the next one. Next one here, we have f of 2. So remember again, I'm looking on my graph where x will be 2. That's going to go ahead and be here on my graph, and I draw a nice highlighted vertical line through that whole x value. Where I circle where is the intersection of that highlighted blue line and my line graph. So that's all the way down here. If you notice, that's the only time this highlighted blue hits my line here. And I can kind of bold that line just so you can see what I'm talking about. Oops. We go ahead and answer with the y value of that intersecting point, which would be a negative 5. Last but not least, the next one says f of x equals negative 3. Notice that we'll need to find the x, but we are given the y value of negative 3. So now I'm going to go to the y-axis down to negative 3. And because it's an equal sign, I'll now draw a horizontal line. A horizontal line because of the equal sign there. Answering now with the x value of this point here, well, the intersection is here with the highlighted line in my given graphed line, and the x value is 0. Let's summarize how we solved this problem. We drew a vertical line through our graph when we were given the x value in our parentheses. So I'm going to just put a highlighter here that this one applies to green and blue. After we did that, we circled the point it passed through and gave the y value of the point as the answer. For the last one, I'll go ahead and talk about this with C. That will be our purple. We did, and we're given f of x equals a number. That's when I draw a horizontal line. I like to reference back to the equal sign because in the equal sign, look what we have. 2 horizontal lines right there. That helps me remember I draw a horizontal line with that equal sign through the graph of the y value. Then I circle the point it passes through to answer with the x value. In our next function word problem, we're going to fill in the table. A sales manager earns a salary of $600 per week. She earns $20 per hour for overtime. We want to fill in the rest of the table to represent this situation. We're first going to define our variables here. My variable x is going to be what's changing and what's going to be per happening. So that word per really attaches to what's changing and happening, which is going to be our hours of overtime. What gets affected by that, because the x is our independent variable and the y is our output or dependent variable, is going to be the salary this person earns. So we're going to go ahead and highlight salary as the output or what's changing based on the overtime. Makes sense though, because the more overtime you do, the more money you make. And that kind of leads one to the other. How we create it is by writing in the form f of x equaling our two numbers we kind of have here. So I have 20 and I also have 600. What's going to happen here is that I'm going to attach X to one of those, specifically my 20, since that's the hours of overtime or money per hour of overtime specifically. And the operation between them is going to be addition because I will be adding to my base salary of that $600 in pink. Now that we have our function, we're going to be able to find the remaining numbers in our table. Whenever it is in the first column, it's going to be your x value, so you'll replace it in place of your function's x. So that's how we solve the first one here. First one here is going to be f of 0, since that's what I'm given, equaling again 20 times 0 plus 600. We're going to go ahead and do the multiplication first, our PEMDAS GEMDAS, to get 0 plus 600. And f of 0 is now equal to 600. So that's what we're going to fill into our table here. In Desmos, I put the function we wrote in step number 2, f of x equals 20x plus 600. Underneath that, to solve for the y values given the x values in my table, I put them in parentheses to replace the x. So f of 0 gave me the 600 we just solved for by hand in our table. And the next one in our table, I see I still have an x value of 15. I plug it in parentheses, and I get 900 as my output y value here. So as you can see, Desmos is going to go ahead and do the work for us. Now doing the work by hand, just to show you for what we just got 900 from, is taking that initial function again, f of x, but in place of x, each time I put 15. And then instead of 20x plus 600, I do 20 times 15 plus that 600. Order of operations tells me to do multiplication first, so that will be multiplying my 20 times 15, which is 300. Then I do my addition to get 900. When I am given the y values now, it's going to be a little bit backwards here. So when I'm given the y value, because that's this second column of money earned here, I got to go ahead and solve it differently. So I have f of x equals 20x plus 600. I can't replace x this time because that's what I'm trying to solve for. That's what I'm missing in my table. But what I can replace is my y, or f of x, with the y value in my table of 840. From here, we solve for x. Draw your line since we have to find it. Subtracting 600 from each side will be my first step here. I get 240 on the left side and 20x on the right side. When I divide each side by 20, I end up getting x is equal to 12. That's what I'm going to put in my table. How we check it in Desmos is again using that same f of x function we had before. I'll get rid of what we already solved for. But remember, I delete and replace that f of x y value with what I have in my table, 840. This time you don't see a gray box come up, so we have to look at our graph, zoom out a bit to find the x value the line passes through, which is 12. Before we do the next problem, let's do it in Desmos first by typing in our next y value of 920. So again, if I'm given that second column y value, I set it equal to my initial and keep the x. Looking on my graph again, because it's not given to me on the left, passes through the x value of 16 as our answer. Of course, we want to show our work here and try it by hand. What I do is I keep that function f of x equaling my 20x plus 600. Keeping the x, we go ahead and erase and replace the f of x y value with 920. Now that we're solving for x, we draw our line and have to do subtraction of 600 from one side to the other. 920 minus 600 is 320, and it equals to 20x. And then I divide each side by 20. Right side cancels out to just x, and left side is going to go ahead and be 16. Again, what Desmo showed us as our answer.